So first things first here, number 1, right? We're given functions f and g. F is 5x. G of x is x squared plus 4. And we're asked to evaluate this, h of x, and h of x is a combination of f and g. Okay? And you'll notice here that for h, okay, that negative 3x squared is being plugged into f. Okay? So if f of x, let's see if I can get both these to fit on here. Yeah. If f of x is 5 times x, then f of negative 3x squared will be 5 times negative 3x squared. Okay? See, the x is replaced by negative 3x squared, so this x will also be replaced by negative 3x squared there. And to multiply that out, it just simplifies to negative 15x squared. Okay? So for this, right, we're going to say that's negative 15x squared there times g of x, which we know is x squared plus 4. So in parentheses, okay, I'll put the x squared plus 4 there. And we'll divide this whole mess by 3. Okay? Now, we have a number, right, a quantity here in front of parentheses. So to simplify this, what should we do with that negative 15x squared? Distribute it, right. So multiply to that, multiply to that. And so negative 15x squared times x squared is going to give us negative 15x to the 4th, right? X squared times x squared, x to the 4th. And then negative 15x squared times a positive 4 is minus 60x squared, and then all over 3. Okay? Oops, off the screen. There we go. Okay? Now, to divide by 3 here, what's going to be divided by 3 in this problem? What gets divided by 3 to simplify this? 15 and the negative 60. Both of these terms get divided by 3. So negative 15 divided by 3 is negative 5. Negative 60 divided by 3 is negative 20. Okay? And so the answer is, okay, letter C. Okay, letter C. All right. Okay. All right. Number 2. Okay, number 2. We're asked to, for question 2, we're going to use these functions. Now you'll notice there's 4 functions here. So we have function 1 right here, Roman numeral 2 right here. There's another function with the graph, just the graph, and there's another graph of a function. And for question 2, we're just asked which ones are even, right? So let's look at these 2 graphs here. Are any of these 2 even? The number 3, Roman numeral 3, is because it's got that symmetry over the y-axis. So this one is even right here. Okay? 4 is not even. It's got rotational symmetry. And in fact, since it's not even, but we could call it what? Odd, because it's got the rotational symmetry. Okay? So it's definitely not Roman numeral 4 because that's odd. And then to determine if Roman numeral 1 or 2 is even, well, let's just graph them. Okay, we'll graph this one right here. Negative 3x to the 3rd plus 2. Let me turn on my light there. Okay, very clearly not even, so it cannot be Roman numeral 1. Okay, and then we'll do negative 6x to the 6th plus 2x, and we'll graph it. Okay, does that look even? Is that even? Kind of like goes up. It's not even here, right? If we were to fold it, it would not match up evenly. So it's not Roman numeral 2. It must be Roman numeral 3 only. So that's letter B. Okay? That's letter B. Okay? So just use your graphing calculator to check. That's the only one that looks, symmetric about the y-axis there, folding over there. Okay? Number 3, there's a couple ways you can do this one. Okay? So again, this is a quadratic function in standard form. Okay? And this is a quadratic function here in a vertex form, right? You have the h, you have the k, right? That's your vertex. So what we could do here is just figure out what the vertex is of this function. So I'm going to do that with my graphing calculator here. This is probably the most easy way to do it. Okay? X to the 2 minus 14x plus 52. Okay, graph it. Okay, I can see my vertex right here. It's a minimum, so I'm going to use second trace and use the minimum command. Okay. make sure I'm to the left of my 0 and hit enter, or my minimum, and hit enter. Go to the right of my 0, hit enter. And then for the guess, we'll go down to the actual minimum and hit enter. And you can see there's my minimum, 7, 3. So that's my vertex. You guys can see it right there. 7, 3, right? And so H is then 7, K is going to be 3, so it's got to be D. Okay? That's my vertex. Okay? You can also find the vertex by using x equals negative b over 2a. So that would be negative 14 over 2 times a. And so negative 14 is positive 7 over, or sorry, positive 14, I mean. Over 2, which then simplifies to 7. So there's the x-coordinate for our vertex. Well, the only one that has positive 7 as the x-coordinate for the vertex, as the h there, is letter D. So it's got to be letter D, right? You can just stop right there. You don't have to find the y value. Okay? Questions on 1, 2, or 3 so far? Questions on 1 through 3? All right. Number 4 then. Number 4, all right, what is the end behavior of the function? Okay, end behavior. So that means we need to know what two pieces of information to determine end behavior. We need to know the power, the degree. Okay, the degree is one thing. And we also need to know the lead coefficient, whether it's positive or negative. Okay, so I have an x, and I'll multiply with an x, and I'll multiply with an x. So that's degree of 3. And the lead coefficient is 1 here, times a negative 3 will be negative 3, times a positive 1 will be negative 3, or negative 3 still. So our lead coefficient is negative 3, which is less than 0. Okay? So odd degree, negative lead coefficient, it's going to look like this. Okay, for the end behavior. Okay? So as we go to the left, we're going to go up. And as we go to the right, we're going to go down. So let's see here. As we go to the left, we'll go up. As we go to the right, we'll go down. It's letter D. Alternatively, you can type this in your graphing calculator. Okay, let me show you. Okay, I didn't foil it out or anything. I just typed it in the way I see it there. And you can look at your end behavior that way. Very easy, right? To the left, you go up. To the right, you go down. There's your end behavior. Don't even have to use anything else. Okay? All right. Number 5. For which of the following values of x is g of x? That's referring back to this function right here. Okay? For which of the following values of x is g of x greater than 0? Okay, so we're going to look at my graph here and determine when is g of x greater than 0. That means when is it above the x-axis? Well, there's 2 places it's above the x-axis. Right here, it's above the x-axis, and right here, we're above the x-axis too. Okay? So we start being above the x-axis from negative infinity up to maybe like, it looks like 1 there. Okay? So from negative infinity to 1, all right, A and C both have negative infinity to 1, so I can get rid of B and D. All right? But there's 2, so we know it's got to be A, right? We know it's got to be A because there's that other section where it's possible. I don't even need to figure that out. If I wanted to figure out where it started, I could use the 0 command. Go to the left of this 0 right here, go to the right of this 0, hit enter, and then there's the x-coordinate where it starts, 2.333 repeating, which you can see that's where we start right here, 2.3 repeating, and then up to 5, and you can count to the 5. 1, 2, 3, 4, 5. Okay, so it's got to be A. Okay, number 6. How many total relative maximums and minimums? Or in other words, these are also, you could say, turning points. Is another way to talk about those. So, how many turning points we're going to have here? Or how many relative maximums and minimums? Total. 2, right? 1 here, and then 1 up here somewhere where we turn around, right? So 1, 2. Okay? 2 points where we turn around like that. Easy. Right? Number 7, factor completely. Okay, now this one's a little bit tricky here. Okay? So one option you have is you could guess and check each one of these by multiplying them back together and see if you get x to the 4th minus 256. Okay? So you can like multiply them back together and see if you get this x to the 4th minus 256. Okay? I'll tell you right now, A and D, you can maybe even see that they're not going to work out right. Okay, those numbers are going to get way too big. We're going to have a 128 times a 64 times a negative 64. That'll be way too big for negative 256. Same here with the 128 and a negative 128. That'll be way too big for a negative 256. Okay, so it's really down between B and C. Now, here's something I'll say. B and C both multiply back to give you the x to the fourth minus 256. So in other words, B and C both are factored versions of this answer. Okay, but C is better because if you look here at B, this is a difference of squares, right? X squared minus 16, that factors further to be x plus 4 and x minus 4. And so it's got to be C is the best answer there, okay? Without even doing any factoring, just kind of like thinking it through and stuff like that, okay? C is the correct answer because B can still be factored, right? That x squared minus 16 is a difference of squares. It factors to x plus 4, x minus 4, which is why C is the correct final answer, okay? Would anyone like me to go through number 7 and factor it fully, like show the full factorization? Yes? Okay. So the way we can do this then, I'm going to rewrite x to the fourth as x squared squared. And I'm going to rewrite minus 256 as, oh gosh, square root 256. Okay, 16. Okay, so x to the fourth minus 256 is a difference of squares. It's x squared squared minus 16 squared. Okay, so for a difference of squares, okay, that factors to a minus b times a plus b. So in this case, our a is x squared and our b is just a 16 here. So this will factor to be x squared minus 16 and x squared plus 16. Okay? Questions on that step right there that I just did? That's the idea here. Okay? And yet we see another difference of squares right here with the x squared minus the 16. And that's why it factors to x minus 4, x plus 4, and then this is that's a sum of squares. We can't factor a sum of squares. Okay. So you can see letter B right here. There's letter B. There's letter B. But that still factors to this one, and that's why C is the correct answer, because that x squared minus 16 factors to x minus 4, x plus 4. Okay? Questions on number 7? All right, keep rolling here then. Number 8. Determine the number of solutions for the system of equations. Okay? How do we solve a system of equations? What's one option we could do here? Yeah, graph them, and then we're going to look for what? Yeah, points of intersection. That's it. And we don't even have to find the coordinates. We just have to find how many points of intersection there are. Even easier, right? So, for those of you that don't know how to type in absolute value, I'll show you here real quick. So first I'll do the negative 1/4 x squared. Again, parentheses around your 1/4 fraction there. Okay, and then to do absolute value, you have to do math, num, and then there it is, abs. Okay, now my calculator has pretty type, so that's why the absolute value symbols show up. If your calculator doesn't have pretty type, it's going to look like this. Let me change it real quick. Math, math, num, abs. Oh, darn it, I put it in the wrong spot. Math, num, abs. Okay. So it's going to look like that. That's your absolute value symbol. That's the start of your absolute value symbol. You'll type in x minus 1, close a parenthesis. So that means x minus 1 is in the absolute value, and then we'll subtract the 2 on the outside. Okay, we'll graph it. There's my quadratic, and there's my absolute value. How many solutions are there to this system? 2. 2, exactly right. Folks, that is like, it doesn't get any easier than that, really, okay? You're literally just typing in your graphing calculator and seeing how many places it intersects, okay? It won't get any easier than that. So please, please, please make sure you can do that, okay? All right? All right, questions on anything 4 through 8 here on this side? Yes? Outside the parentheses? Yeah. Because really, I only put the 1/4 in parentheses because it's a fraction. Whenever you type fractions to the calculators, I recommend you put parentheses around the fractions. X squared, yeah, it should be fine. So, okay. All right, now, number 9. This one, okay, and so for those of you that maybe were tuning me out, you definitely want to tune me back in here real quick, okay? Number 9, there's 2 main ways you could do this. Option 1 is to guess and check your x, so guess and check A, for example, and you plug in -3, -2, and 4 for the x, y, and z and see that you get 4. And then you plug it into this one right here for x, y, and z and see that you get -5, and plug it in here to see that you get 13. Okay? If one of these equations fails using these points, then that means that is not your solution. Okay? Same thing, then you'd go down to B and check it in. Put -2 in for X, 4 in for Y, -3 in for Z, and see to get 4, so on and so forth. Okay? That's one way to do it. The other way is to use matrices on your graphing calculator. And this is one I showed you guys for that one test that we did here. So the way you do it, to do a matrix in your calculator, there's a matrix command right down here. Okay, you can see it right there. It says matrix. So you're going to press second x to the -1, and it takes you to this window here. Okay. We're going to go over to edit, because we're going to put some information into a matrix before we can then use the calculator to solve it. So we're going to hit enter. And then our matrix, okay, it's going to be 3 rows and 4 columns. Okay, so a 3 by 4 matrix. Why 3 rows? Well, how many equations do we have? We have 3, right? Why 4 columns? Because we have 1, 2, 3, 4 columns of numbers here. Okay, so we're basically going to make one big matrix. There's a column, there's a column, there's a column, there's a column. Okay? So what am I going to put in for the numbers here? I'm just going to use the coefficients. So -5, 3, 6, and then 4. -5, 3, 6, 4 across the top. And then -3, 1, 5, -5. And then -4, 2, 1, 13. Okay? So we're just putting all of our coefficients in order. Across the top, across the middle, across the bottom. Okay? Is anyone typing that in right now? Taylor, are you typing them in right now? Yeah. Okay, I'll wait. Anyone else typing them in right now? You are? Ashley, are you typing them in? Okay. Tell me when you guys are done then. I'll show you what to do from there. Okay? Everyone else, I'll go ahead and show you while they're typing stuff in. So just real quick, you're going to quit back out, go to your home screen, go back into the matrix menu, and you go over to math. Now that we have our matrix entered, we need to tell the calculator to do something with it, and we're going to go from math down to RREF. RREF, okay, row reduced echelon form. Okay, so you're going to select that. So again, Taylor, Ashley, second matrix. You'll go back to math, and you go to RREF. You got to quit out of the matrix once you've entered all your data in. Quit out, go back to your home screen, then go back into the matrix stuff. Go to RREF, okay, like that. And then we're going to tell it to do it to, again, second matrix, and we'll tell it to do it to matrix A. Okay, so RREF, matrix A, hit enter, and then there are answers, -2, 4, -3. So the answer is B. Okay, the answer is B there. Okay, got it okay? No? Did you get a different answer? So arrow over to math. Go down to RREF. Hit enter. And then it should be on your home screen now. Oh, okay. That's an issue. Sorry. We have to go back to the home screen, then hit second matrix, go to that RREF. And then you're going to tell us to do it to matrix A. Actually, you get it okay? Okay. All right. So again, you don't need to use the matrix here for this one. You could literally just guess and check each one of these in and see which one gives you, a solution to all 3. All right. We'll stop right there. I will finish this video up during my planning. Did you get to finish here? Okay. I'll finish this video up during my planning, and then tomorrow and in set, I'll answer more questions on this first one, and we'll get started on the second one too. Okay. So I'm going to go ahead and finish up the rest of the review here. There's no class, so I'm going to ask questions to no one, so you can think about them on your own if you're listening to me at home. Okay, and if you need to, of course, pause, rewind. You can use the arrow keys on your keyboard to jump back 5 seconds or 10 seconds. I forget which one in time. Stuff like that. You can slow me down if you need to. You can speed me up if you need to. You can jump back and forth, just like jump in the video and stuff. So whatever you need to do. All right. To follow along here. We're going to continue along here. Number 10, factor. Unfortunately, there's no real way to do this with the graphing calculator. You have to just do what it asks you to do. Okay, now looking at this, all right, I see there's no immediate GCF I can factor out, right? These three terms all have x's, but this one does not, right? All the numbers, I should say, are not divisible by anything, but I can see there's 4 terms here, which means I can group. So I'm going to group the first 2 and group the second 2. From the first group, I see that I can take out a 2, and they also both have an x. So I'll have a 2x that I pull out, and that will leave behind an x squared from here. If I take out a 2x here, I'll be left with a y to the 5th. Okay? From this group right here, I can take out a 3 and a z, it looks like. And then what will be left behind here is, well, an x squared, and then a y to the 5th. Okay, now, looking at my results, I can see that I get an x squared and a y to the 5th, so I'm going to take those out as well. And what will be left behind? Well, the 2x and the plus 3z. And there is my answer, which corresponds to letter B. Okay? All right, number 11, solve the following quadratic equation. Okay, so option 1, anytime you're asked to solve an equation, you can graph the left-hand side, graph the right-hand side, and find the x-coordinates of the points of intersection there. So I'll do that here briefly. Okay, I know you guys know how to type things in your calculator, so I'm not going to spend like an hour doing that here. I'll just do it real quick. Please use parentheses where it says to. Okay, I'll graph it. There's my left-hand side, there's my right-hand side. You can see there's 2 points of intersection here. It's kind of hard to see, but I'll do, let's see here. I should be able to, well, maybe not. Okay. Second trace, we'll go to intersect. Okay, first curve, yep. Second curve, yep. And I'll just guess it right there and see what we get. Okay, I get 0.33333, comma 0. Okay, so one solution is 1/3. So that means A cannot be it and C cannot be it because neither of those have 1/3 as an answer. All right, now I just need to figure out if I intersect at 1 or if I intersect at 2. So second trace, intersect again. I'm going to go a little bit further to the right here and hit enter, enter, enter. And I get 1, 4 is my other solution point. So it's letter B that has the 1/3 and the 1. Okay. If you don't want to use the graphing calculator to do this, to solve your equation, another option you have besides graphing the left-hand side and the right-hand side is you can guess and check your answers. You can literally just plug -3 in for x here, plug -3 in for x here, simplify the left, simplify the right, and see if you get the same thing. Okay. If it makes the equation true, then you know that that's an answer. If it does not, then you know that's not an answer. Okay. That's another way you can do it, is guessing and checking with just the answers. And then thirdly, the more straightforward way we're supposed to do it here is by actually simplifying this. So you get 6x minus 2. Squaring this really means then 1 minus 3x times a 1 minus 3x. So we'll get 1 minus 6x plus 9x squared. Subtract everything over here, we'll get 0 equals 3 minus 12x plus 9x squared. Or if I flip it around, 9x squared minus 12x plus 3. Okay, at this point you can use quadratic formula if you want to, or you can try and factor it. I see here that I could pull out a GCF of 3 if I'm going to factor, so I'll pull out that 3. I get 3x squared minus 4x plus 1. And then I can use my, product sum method, so A times C. So A is 3 times 1, so I get 3 times 1, which is 3. I'm looking for 2 numbers that multiply to positive 3 but add to make negative 4, and that would be negative 3 and negative 1. Sorry. So negative 3 and negative 1 multiply to positive 3, but they add to make negative 4. And so this will factor further to be 3x squared minus 3x minus 1x plus 1. I can then group these two and group these two. I'm going to have to kind of go up this way. All right, so we'll have a 3. I'll pull out a 3x from this group, leaving behind an x minus 1. I'll pull out a negative 1 from this group, leaving behind an x minus 1. There's the x minus 1 in common. So I'll have 3x minus 1 and 3x minus 1. Okay? And so there you can see I can set that, and these are all equal to 0, of course. So I can set that x minus 1 equal to 0. Okay, I can set the 3x minus 1 equal to 0. And there you can see where you get your 1. And here you can see where you get your 3x equals 1. And so x is 1/3. Again, going up this way. Okay, so there are your 2 answers that way, too. Whoops, I went off the screen. There we go. Okay? So again, your choice. graph the left-hand side, graph the right-hand side, find the points of intersection, guess and check your answers in the equation, or multiply it out, get it equal to 0, and then factor. Okay? 12, all right, again, another option where you could guess and check. So in other words, you could plug 5 in for your a's here, okay, and simplify to get the coefficients, and then use synthetic division to see if x plus 1 is a factor, okay? If 5 works, then you can keep that one, then you should check -1, okay, and go from there, okay? So that's one option. And of course, if 5 doesn't work, then you can throw out A, you can throw out D, and then you can try -1 and see if that one works as well, okay? Now, let's say you don't want to do it that way. You don't want to guess and check. You want to do it the straightforward way. Well, the way we're going to do that then is we're going to use -1 in our little box there for synthetic division. We'll put A squared, okay, in for the lead coefficient here. Then I'll put -A minus 4 in for the next lead coefficient, and then I'll have 3A for the next coefficient, and then I'll have a 9 for the final. Okay, I'll drop down the A squared. A squared times -1 is -A squared. We're going to add these, but there's no like term, so we're just going to have -A squared minus A minus 4. All that gets multiplied with -1, so we'll have A squared plus A plus 4. Add these together, we'll now have A squared plus 4A plus 4. And I kind of run out of some space here. Okay, and then times -1 will be -A squared minus 4A minus 4. We'll add these here, so we'll have -A squared minus 4A and then plus 5. Okay, we want to know, right, if x plus 1 is divisible, or when this is divisible by x plus 1. So for it to be divisible, we would want our remainder to be what? We would want our remainder to be 0. So we're going to take our remainder here and set it equal to 0. Okay, at this point, you can also put this in your graphing calculator, okay, graph it and see when it crosses the x-axis, right? So find your zeros that way. Or we can factor, or we can use quadratic formula. Or now you can guess and check your a values in if you wanted to. So your choice. I'll go ahead and factor it, again, for the more kind of straightforward approach here. I don't like having a -A squared, so I'm going to multiply both sides by -1, so that will give me A squared plus 4A minus 5 equals 0. I'll then factor this. Okay. You can use product sum here, but I'm going to factor this just kind of quickly mentally. Okay. So there it is. And so you can see we'll get A plus 5 equals 0 and A minus 1 equals 0. We'll get A equals -5. We'll get A equals 1. Okay, so the answer is C. Oops, sorry. All right. So again, guess and check by plugging in your A's and then checking with synthetic division if x plus 1 is a factor or divides it evenly. Okay. So and then you can see which ones will work and which ones won't. Okay. Number 13. What simplifies to a real number? Okay. Option 1 is you could multiply all these out. Option 2, and actually simplify them yourself. But option 2 is you can type these in your calculator. Remember, 3 minus 8i squared. And you can see imaginary answer there. Okay? Imaginary answer there. Okay? So not real because it's got an I. Okay, well now we'll try 5i to the 11th. Okay? Oof. I feel like this one's hard to see. So 5 to the 11th is that number. I to the 11th. Okay, you can see we're going to have an I there. So that's imaginary as well. Okay? We'll do 4 plus I minus 4. Oh, wait a minute. That one's not imaginary, I think. Oh, yeah, I think that's actually simplifies to 0. I think this one's hard to see. All right, let's hold off. Maybe it is B. Sorry, maybe it is B. Let's just hold off on that because we get a weird result in the calculator there. When I did 5i to the 11th in the calculator, I got a weird result. So let's hold off on that. Oh, wait, now I can arrow. Okay, so no, it does have an I there, so never mind. It shouldn't work. All right, let's try this one then. 4 plus I minus 4 minus I. There you go. Okay, 4 plus I minus 4 minus I. We get 2I, imaginary. So it's got to be D, right? But let's just check to make sure. 7 plus I, 7 minus I. Okay, again, just typing on my calculator, hitting enter. Aha, see, no i's. So D is the answer. Okay. Which of the following equations has a non-real solution? Non-real solution, imaginary solutions. Okay. So here you can notice they're all quadratic. Right? That'll be quadratic too. And so we want to see which one of these are going to have non-real solutions. So you have a couple options here. Okay. I would say probably the most straightforward way here. Well, so since it's just quadratic, we could graph the left-hand side, graph the right-hand side, and look for points of intersection. If there are points of intersection, okay, that means we have real solutions. If there are no points of intersection, that means we would have non-real or imaginary solutions. Okay, so you could graph the left, graph the right, look for a situation where you never intersect. That's option 1. Option 2 is we could get this equal to 0 and then use the discriminant, b squared minus 4ac, and we'd be looking for a negative discriminant. Okay? Or alternatively, you could just try and solve this using quadratic formula. Again, you have to subtract the 2x, subtract the 4 over. So this would become 3x squared minus 9x minus 3 equals 0. Use quadratic formula here, okay, and see if you get a square root of a negative number. That would be non-real. Okay? Alternatively, you could also graph this now. So again, I know I said you could graph the left, graph the right, and look for points of intersection. You'd be looking for a situation where there are no points of intersection. Here, you could also graph this quadratic equation and just see if there's any situations where, okay, so there, I'll just graph it. Okay, here we can see the graph crosses the x-axis in 2 places. Those are real solutions, so it's not A. Okay, not A. All right, we can try B. We'll just add the 1 over there, so we get 8x squared minus 7x plus 1 equals 0. Okay, graph that. You see we still intersect the x-axis there, so All right, I can type this one straight in because it's already equal to 0. Okay, there's letter C. Again, I can see 2 zeros there, so nope. So it's got to be D. I'm going to add the 3 over here, so that way it's equal to 0. I don't need to multiply this out. I just need it to be equal to 0. So I can just leave it like that. So that's a funky X. There we go. Okay? So. Oops, minus 2. Okay, put the plus 3 there. Graph it. Okay, you can see this graph never intersects the x-axis. It's got to be D. Okay. All right, number 15. This one you can notice all of the functions are the same. The only thing that's different is the sign, okay, and the direction of the sign. So, since we have a dotted line here, we know that we will not have B or D because dotted line means there's no equal to's, and B and D both have an equal to there. Okay, we are shaded above, so we want to shade greater than our curve. So y greater than that, it's got to be C. It's as easy as that. You could also, well, you could type in your graphing calculator, but you can't really get the shade. Yeah, I would say no. I would say that's your best bet there. Okay, so go with that. All right, now on to the free response questions. Evaluate f of negative 5. For number 16, this is literally just plugging negative 5 in. So f of negative 5 is 6 times negative 5 in parentheses squared plus negative 5 in parentheses minus 2. Okay, you can now type that whole mess in your calculator if you want to. And you get 143 as your answer. Okay, h of f of x. You'll notice f is inside of h. So we're going to take f, we're going to plug it into the x here for the h. So h is 2x minus 1, so we'll do 2 parentheses f of x. Okay, so 2 times f of x minus 1. Okay, we're just taking that f of x, plugging it in for the x right here in h. Okay, so there it is. And we'll just simplify it out. So distribute the 2. I still have the minus 1, and then combine the minus 4 and the minus 1. And there's your answer. Okay. C, subtract. So we'll take 6x squared plus x minus 2. And we will subtract g of x, which is x squared minus 5x minus 14. Subtraction in front of parentheses means it gets distributed. So I'm going to change to plus, and I'll make this negative, positive, positive. Okay, just add the opposites there. So 6x squared and negative x squared becomes 5x squared. Positive x and positive 5x is 6x, and then negative 2 and positive 14 is 12. There's our answer. Okay. Next, we're going to add, that's a division. Divide f and h. So 6x squared plus x minus 2 divided by 2x minus 1. Okay. We technically need to use synthetic division here. So we're going to use, we technically cannot use synthetic division because it's not x minus 1, it's 2x minus 1. So we need to use long division here. Okay, so 2x minus 1 divided into 6x squared plus x minus 2. Okay, and now we'll do what times 2x gives me 6x squared. So I need a 3 to make 6, and I'll need an x to make an x squared. So 3x times 2x, 6x squared. Okay, I know I'm right. 3x times minus 1, minus 3x. And again, we subtract the quantity there. Instead of subtracting, I like to change it to add the opposite. So that cancels, and then x and 3x makes 4x. Bring down the minus 2. What times 2x gives me 4x? Well, it's a 2. 2 times 2x gives me 4x. Aha, they match up. Good. 2 minus 2. We'll subtract the quantity. And these, well, they're going to cancel. We get 0. And so there's our answer, 3x plus 2. Okay? Finally, we're supposed to square h. So what is h? H, remember, is 2x minus 1 from above. And we're going to square it, which means you multiply it by itself, which means we have 2x times 2x, 2x times minus 1, so 4x squared minus 2x, minus 1 times 2x, minus 1 times minus 1, so minus 2x plus 1. And so that simplifies to then 4x squared minus 4x plus 1. Final answer. Okay? Number 17, okay? This is a transformation of the absolute value, okay? Right? We're shifting things right 1, down 6, and then we are also vertically shrinking by 1/2. Okay? So we're going to graph it. So we're going to go from the origin here. Be careful. Each block is counting by 2. So we're going to go right 1, that's right here, and then down 6 to here. So there's our point. And then we're going to use our slope to go up 1, right 2. Up 1, right 2. Up 1, right 2. Up 1, right 2. Okay, but also up 1, left 2. Up 1, left 2. Up 1, left 2. Up 1, left 2. You can also type this in your graphing calculator and use your table to get some points for you to graph too. So you can just type it into y equals and then go to second graph for the table and then use those table points. I'm going to go ahead and finish this though. Okay, with the graph we can identify the range. Okay, remember range describes the y values. And for the range you want to go from bottom to top. So the bottommost point here of my graph is at -6. So we're going to go from -6, including it, all the way up to, well, these arrows keep going up and up and up, so go to infinity. Okay, just like that. All right. C, given g of x equals -4, for what values of x does f of x equal g of x? In other words, we want to take our f of x here and set it equal to our g of x of -4. Okay? Now, a couple options you could do here. One, you could just solve this using algebra. Okay, add the 6 over, multiply both sides by 2, break it up into 2 equations. You could graph the left-hand side, graph the right-hand side, find the points of intersection. But you already have the graph right up here, and we can graph -4 very easily. It's just going to be this horizontal line. And where do we intersect? Right here and right here. And what are those coordinates? -3, -4. So x equals -3, and x equals +5. And there are your 2 solutions without having to do too much extra work there. Okay, that's g of x. That's f of x. Okay. Letter D, we're now going to use h of x. We're going to graph h of x. H of x is our old function f from up here, but we're going to shift it left 5 and up 3. Left 5, up 3. So we were right here. We're going to go left 5. So 1, 2, 3, 4, 5. We're at -4. And we're going to go up 3 from that. 1, 2, 3. So we're at -4, -3. Okay? There's no change to our slope or anything like that. So we're still going to go up 1, right 2. Up 1, right 2. Up 1, right 2. Up 1, right 2. and then up 1, left 2. Okay, and connect the dots. This one's going to be harder for you to type into your calculator, okay? Yeah, this one's going to be harder for you to type in your calculator. So you'll want to know just how to shift things for this one particularly. Okay? On what interval does h of x have a positive rate of change? That's the same thing as a positive slope. Okay, and we have a positive slope here, right? So where does it start being positive? At -4. We're not going to include -4 though, because at -4 it's not clear whether it's positive or negative, right? But from -4 and then to infinity, right? It keeps going to positive. All right, last but not least, from 3 feet above home plate, Billy hits a baseball upward with a velocity of 77 feet per second. The height of the baseball in feet at time t is given by this equation. So h is height, t is time, okay? H is height in feet, t is time in seconds after the baseball is hit. What is the maximum height reached by the ball? Round your answer to the nearest hundredth. Maximum height, so we're going to graph this. Okay, it's quadratic, right? So quadratic functions, the maximum will be at the vertex, okay, or the minimum's at the vertex. So let's graph it here and see what we see. Okay, very clearly I need to adjust my window, right? I don't need to go any wider necessarily, but I do need to go up because my graph's going to come up here and curve back down. So window, and let's adjust my x max to be like 50. Whoops, x max, that was the wrong direction. I'm going to keep my x max 10. Y max of 50 to go up more. Not high enough. Window, let's try 100. Okay, I'm going to go a little bit more. Let's say like 120. Okay, that's perfect. All right, so I'll find my maximum. Second, trace, maximum command. Make sure to the left of the maximum, I am. I'm going to go past it and then go to the right of it and hit enter. And I'll go up to the top and guess it. Okay, and there's my maximum. Okay, so I have 2.4 nearest hundredth. So 2.41 we'll say, comma 95.64. I'm going to write both points down because there's a good chance I'm going to use both of these. Okay, now, first question asks what's the maximum height? Maximum height is h, or our y value here, so that's your 95.64 feet. How many seconds does it take for the ball to hit the ground? Okay, now that we want to know when it hits the ground, that's when the height will be 0. So we go back to our graph here. There's where the ball was hit. It's going to go up, 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 down, 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 and there's where it's going to hit the ground. So I'm going to hit second trace, and we'll go to the 0 command. Okay, make sure you're to the left of your 0, hit enter. Make sure you go to the right of it, hit enter, and then go in towards the guess, hit enter, and there you can see at about 4.85 seconds. Okay. Letter C, a bird behind the bleachers gets spooked at the same time that Billy hit the baseball. It flies up at a constant speed. The bird flies up at a constant speed. The equation describing the bird's height is g of t equals 21.4 t, where g of t is the height in feet of the bird over the ground, and t is the time in seconds. So at the same time that Billy hits the baseball, the bird is flying up. After how many seconds will the ball and the bird pass each other? Round your answer to the nearest hundredth if necessary. So pass each other, that means they're going to be intersecting, right? So we're going to, or have the same height, I guess we should say. So I'm also going to graph simultaneously 21.4x. Sorry, you can see it right there now. Okay, graph that as well. Okay, and there's where they're going to hit, right? They also hit down here, but that's like a negative time and a negative height. That doesn't make any sense, right? Out of context. So second trace, intersect command. Okay, first curve, I'm on my parabola. You can also see it right here that's listed there. Second curve, I'm on my line now, hit enter. And then for the guess, I'm going to go up towards the actual point of intersection, hit enter. And there we can see. Okay, so after how many seconds will they pass each other? At about 3.53 seconds. Okay, and then using your answer for C, what is the height when they intersect? Well, that's easy. It's right there, 75.50. Okay, and that concludes the video here. Okay, feel free to go back and review if you need to. Okay, rewind. Of course, ask me questions in class. And yeah, good luck with your review.